This is the second video on vector geometry, and we're going to continue to look at some more complicated problems that we can solve using vectors. So here we have OPQR is a trapezium with PQ parallel to OR. We're given several vectors. OP is 2b, PQ is 2a, and OR is 6a. M is the midpoint of PQ and N is the midpoint of OR. And you can see from that I've made PN is equal to A because it's half of PQ, and ON is equal to 3A because it's half of OR. So find the vector MN in terms of A and B. So MN is this vector here. So to do that, we're going to go around 1, 2, 3. So MN is equal to MP plus PO plus ON, and that is equal to minus A minus 2B plus 3A, and that gives us an answer of 2A minus 2b on vector Mn. Now in the next part, we're told that x is the midpoint of Mn. So here we have x, and y is the midpoint of QR. So over here we have y. We're asked to prove that xy is parallel to OR. Now remember that two lines are parallel if one is a scalar multiple of the other. So if we can write one as some number multiplied the other, then they are parallel. So let's have a look at these. We know OR is 6a, we've already got that. OR is 6a, that was nice and easy. So we need to work out xy. So x, y, one way to do this would be to go up here, across and down. So that would be xm plus mq plus qy. Now we know mq is nice and easy. Xm is a half of nm, so that's also nice and easy. And qy is the one we need to find because that's part of qr and we don't know anything about qr. So first thing we can do is xm, well that's a half of nm. So it's a half of the negative of this. So we have to add on a half of minus 2a plus 2b plus mq is equal to just a because it's a half of pq, and then on the end qy, or we can call that a half of qr. Now, if we work out QR, let's jump down here. We've got a bit of space. QR is equal to minus 2a, that's QP, so it's minus 2a. Then PO, which is minus 2b. And then OR, which is plus 6a. So QR in total is 4a minus 2b. So if we now substitute that in up here, we have, we're multiplying this out, we get minus a plus b plus a plus a half of what we just worked out. So a half of 4a is plus 2a minus a half of 2b is just minus a b. Simplifying this, we have minus a plus 2a, so that gives us 2a plus b minus b, the b's cancel. So xy is equal to 2a. So, let's say OR is equal to 3 times by xy, and that implies they are parallel, because one is a scalar multiple of the other. So now let's look at this final problem. We've got a lot of information that we're given. OA is 4A, OB is 4B. We're told that what looks like straight lines, OAC, OBX, and BQC are all straight lines. We don't know about AQX though. We're told AC is equal to 2OA. If AC is equal to 2OA, that means this one here is 8A. BQ to QC is in the ratio 1 to 3. So BQ times by 3 is QC. So in total we have 4 parts. So this is 1/4 of that length, and this is 3/4 of that length. Now find in terms of A and B. First of all we want to find BC. So BC, we go back and then up to get from B to C. So BC is equal to BO plus OC, which is equal to minus 4B plus 12A. AQ here, AQ, one way to find that is to go down here to O, across and then up. So that is equal to AO plus OB plus BQ. AO is minus 4A, OB is plus 4B, and BQ, well BQ is 1/4 of BC. So we have minus 4A plus 4B plus 1/4 of what we had before. That's 1/4 of minus 4B. So that is minus a B, and 12A becomes plus 3A because it's 1/4, which gives us minus 4A plus 3A, gives us minus A, and 4B minus B is plus 3B. So minus A plus 3B is AQ. In part B, we're told that BX is equal to 8B. So we're told that this measurement here now is 8B. Show that AQX, this line here, AQX, is a straight line. Now, to show that something's a straight line, we show that the small line, that's AQ, is parallel to the big line, AX. And the reason that works is because if AQ and AX are parallel, they're in the same direction, but as they both go through Q, they must be the same line. So we have that AX is equal to, well, that's along here, so that's minus 4a plus 12b, that's ax, and we can factorize that to, let's say, what are we aiming for? We're aiming for a q we want, which we've already got, so if we factorize this, we get 4 up front, minus a plus 3b, but minus a plus 3b is what we had over here, so that is equal to 4 lots of a q. So ax is equal to 4aq, which implies they're parallel, but because they both share the point A and they both go through Q, we also know they're the same line, which implies that AQX is a straight line. So that's how we can use vectors to solve some geometrical problems, like finding if two vectors are parallel and finding if 3 points are on the same line.